Good afternoon. Let's continue to explore everyday life of the data analysts and business analysts. In previous webinar, I invited you to learn the basics and get to know the Power BI ecosystem in practice. Today I invited you to explore two major issues, or how we name them in our course, two blocks, number 3 and number 4. Some general comments about those blocks, why they are included in this course. The block 3, with name Start to Work with the Data, it's very important to understand that it's necessary to acquire skills and on how to prepare the data from the different data sources, to not be confused in non-standard situations. In this block, you will be guided through different situations and will be shown how to have a deal with them to get your data into your project. The block 4, with the name Let's Talk with the Developers, it's about the lean product culture, in fact. Why it's so important? When you, for example, build the house, all depends the foundations of these buildings. In the same, also, if you want to build a nice reports, all depends from the data models on which they are based. How tall or complex a building you build, it depends on the foundations. If they are good, there will be possible also to create nice buildings, which comes in the history probably. So there I give some considerations how to maintain this flexibility in reporting by correctly building these data models to start to build, because nothing is more expensive than try to rebuild all already existing structures. Therefore, better we will try to learn how correctly to start to build those data models. I will start with this block 3, how to get data in Power BI projects, and focus just on the 3 most commonly used data types. Data from web, data from Excel, and data from CSV. But I will show just main points on which you probably should focus at the beginning. All additional things you will learn, you get these skills going through these Microsoft Learning materials. Let's start with the web data. They are most freely accessible for everyone. And there, as an example, is shown from the Wikipedia web page, where is shown the date web page where is collecting all the information about the European Football Championship. So you can simply look and can go through. There is some tables, you can look in these tables, find the information in which year, what was the winner in semifinals, which participate, what is the scores, and so on. All the information about the championship. But our particular interest, for example, will be just to take what is the winners on these championships on some particular years, to build to take these data as a table in our Power BI project. So, what we are started for? We opened our Power BI, there is the main view of the Power BI. We're simply going up to the Home tab, look for the Get the Data icon, scroll down till the Web icon, and select that. There will be open new windows, which navigates you through step by step this process, how you get these data from the web on your project. Simply on this basic form, you, for example, copy the internet address of this particular page from where you want to take this table and select OK. The new windows will open, navigator windows, where this app will collect this information from the web page and simply shows you all tables as it understands on this page that they are looks like the table. There is some marks in this code of this web page code that shows that these are the tables. And as you see, probably when you go through this web page, you see just 2, 3 tables, but in fact, this app found that there on this page are more than 3 tables. You simply can click on each of those tables, and you will very quickly find that the information that interested you are under these table results. You select that. You click in this checkbox to select this table. There is possible to choose not only one table. Once you can choose all tables, or make some selection of the tables. Okay, but in this case, we select just one. And then you make a quick look on this preview pane, and you see that, no, in fact, it doesn't look so as you want to import. You need just the first column, you need the fourth columns, all other columns are not required in your project. And also there is some problems with the records in these cells, because with the year that comes also the word details and so on. That means there will be necessary to clean up a little bit those data. And therefore, you do not choose simply the load, but you select the option transform data. As you do that, transform the data, a new windows will open, the Power Query editor will open. And there you can make transformations with those data that you want to import in your project. In this case, particular, just for the example, we want to import first and fourth column. So I select the column 1, keep pushed Control key, select column 4, and then right-click on the mouse. Right-click always on the mouse is very, very useful tool, in fact, because it always will show to you the most commonly used operations that is available in this situation. And you don't have to look all around on the tabs to look for some functions, operators to do something. All main tasks that you can do in these situations are available here. In these situations, we want to remove all other columns that are not selected. It's more easy to select 2 and drop 10 columns than select 10 and drop them. Therefore, in the Power BI, there is this possibility, as you see here, remove other columns. That means you drop all other columns except those that you are selected. Of course, if you do not like to work with this right click on the mouse button, then you can simply look on the upper tab for this icon, remove columns, and under them you will see these options, remove the columns or remove other columns. So we remove other columns, and then we have just 2 columns. And then we see that in this first column, where should be just the years, there also in each cell, you'll see, also, not in each, but in some cells, you'll see this word details. We should remove it. Again, select the column, right click, and then what you can do, and I think there you will see large similarity what you can do also when you work in Excel. Replace. You choose these replace values. Write value what you want to replace, that means the details. To replace with, leave the empty or the blank. So these details in this column will be replaced by nothing. Will be stay just the numbers. Click OK. Then the next view, you see that yes, this will help you to solve these problems with information that it's not necessary to keep in these cells. Make a quick look on this first column again. There should be just the numbers, but as you see, there is also in some rows the word year remains. We should remove that. Of course, it's possible to remove particular lines, but when you will refresh the data, that means reload the data next time, probably this name year will stay in the 9th row. There will come at the beginning some additional row, and it shifts downward by 1. If you at this moment say in the transformations, let's drop the row 9, next time also will be dropped the row 9. Better what to do, simply on this row where is the column names, in this first column right hand side, choose this drop down button, and there in the filter area, simply uncheck this word here. And with that, there will stay just the numbers. So, next, when it's done, as you see on the top row, there is just the names columns. But you need to put the real names. That there is the year in the second column, which currently calls column 4. You should add the name, for example, winner. So again, right click, use options list, and select rename. And one by one, you will rename those columns. That, in fact, will be all in this situation that you have to do. But before I say those final words for this import procedure, close and apply, always make a quick look on the far right side on this view, on the last tab on the right. Where is the properties name? Because it's very important to give for every object self-explanatory names. It pays off very quickly when you need to manage many tables and variables. Therefore, also here, automatically for this table from this web, the name is results, but let's give the better name for this table, Euro Cup winners. One additional remark. On the same tab on the right-hand side, you will see this section applied steps. And there you can see what you do with your data during the import process, step by step. If you found out that something goes wrong and you have to go back some steps during those data importing, there is no such option that undo, but there is an even better option. You simply can choose, for example, delete some step, this last step, for example, or simply choose this gear symbol to open and refresh what are you doing with your data, to make some customized changes in this step. When all is done, and you understand that now it's finished with that, simply close and apply. You can choose, select close and apply. All will be saved and data will be loaded to the project. Very similar process is, in fact, the same process happens when you work with the Excel data or CSV data. Those first steps will be a little bit different in each time. And for example, here with Excel data, again, you stored some Excel file with 2 worksheets somewhere in some folder on your local computer. Again, on the Power BI, its main view, on the Home tab, select Get Data, scroll down to Excel, select Excel, then you navigate through all these folders till the folder where this Excel are stored. Open it, and this app automatically read that this Excel consists of the 2 tables. Here's some preview. You just have to select which worksheets you want to import, and of course, simply to load all, or if it's necessary before the load, you have to make some transformations of the data. All the further steps will be the same as shown before. There will be no differences. The same with the CSV files, which is very, I think, the most popular, the file type to share with data between them that analyzed. Also here, you simply select the Get Data, scroll down to CSV, and then this opens this navigation. And first of all, you navigate to your data file. Afterwards, when it's opened, there will be no options about the many sheets in the CSV file, all written on the one sheet. So there will be other things that you have to choose. In the Baltic countries, we use some specific letters. Therefore, sometimes there is some problems with encoding, and therefore there is necessary first of all choose appropriate coding. UTF-8 is most commonly used for the Baltic countries languages. Then you should select delimiter. It tries to automatically figure out what is for the delimiter of the columns, commas or semicolons, probably tabs. If you will see here information in this preview, not as a table, but simply as a text rows, then simply change the limiter. During this text, we'll see those limiters. So again, try to be flexible. do not be confused if you see something different in your computer from those learning materials. Try to change this environment, change all those data. Nothing you can, there will be no mistakes. Yeah. But by trying, you can get those data for sure in your project. Those data, what you've taken from different sources, of course, times to times have been updated. And then also you should update the data in your Power BI project. To import those data, it's not very hard. You will see on this Home tab, this button, Refresh, but what you have to take in account. Power BI imports the data from the original data sets. And if those original data sets are large, then also you have to be ready that this will take a time to refresh also this data in your projects. Because whenever you refresh those data and try to understand that there are three processes it goes through. First of all, Power BI try to connect to these data, to read them, to understand what those data are. It takes time. As bigger this original data set, much time this will take. Then it's necessary to load those data to your project. And again, it's also take time. Afterwards, when those data are loaded, and you already have built some reports or dashboards, with those new data, also those reports, those visuals should be updated. And again, that take a little time. So it's not a good practice to try to update with the newest data something when you know that after the 10 minutes you should already present. Therefore, always take into account if there is some complex dashboards, some complex projects, try to update. Take into account that this could take more time than sometimes you are expected, in fact. But sometimes also things goes wrong. And the first simple thing, what you should do, it's no need to start to look where on those import processes something is wrong, or does probably some data source storage place change on something like that. But most usually there is one simple solution. Make sure that you are signed in to the data sources. As an example, you store your data on some cloud. You have to log in to this cloud, but make sure that you are checked this thing. Keep me signed in this cloud, because sometimes if you are doing not that, you don't do that, you close this connection with the cloud. When you next time try to open again, you have to sign into that. But if all things succeed, as you will select this, close and apply, data will be loaded and you will be returned back to the report view in your Power BI desktop. And Here, you can start to work with visuals, and you will see the tables that you are imported. And if you will expand those tables, you also will see the variables that are available for those visuals. So, about the second block, block number 4, how to talk with developers. Try to think in the lean project way. Try to minimize the data that you will load to your models. There, of course, is these limitations by the software that you used in Power BI. Also, it depends from the particular programs. Are you use simple shared capacity in the Power BI Pro, for example, or you use the premium capacity? There will be differences, what size of data models you can load. But of course, the most important for such simple models will be with the smaller models, you can achieve faster data refresh. This will result in a smaller latency of what you see on your screens. That means, for example, if you choose some filters with the smaller data models, as you something choose on your report, all will change. It will seem immediately. But if there behind are the very large, very complex data models, then you sometimes when select something in your reports, also have to wait why these reports will be updated. Of course, also the smaller, when you're working with the smaller data models, it's more secure for the data refresh. When you load big data models, it takes time to update those models. What could happen if, for example, your internet connections will be interrupted during those loads? If those large data models are large, the probability of this interruption also is higher. If those data models are smaller, they load faster, they loads as a chunk. So also these probabilities that something will go wrong during these updates become smaller. There is an 8 techniques how to reduce those data models, the size of your data models. But at the beginning, simply pay attention on the 4 techniques. Do not carry the lost weight. That means do not take in your data models unnecessary columns. With this example from the web page data import, if you know that in the report you will use just 2 columns from 10, in data model, load those 2 columns. When will be necessary to add some additional column, you always can go back to this process where you're importing the data and make changes to add this 1 additional column. Do not take in your models unnecessary rows. Simply talk with the business side. For example, you have access to the company data from the 2012. But after the talks with the business, you figure out that in fact, for the comparison and also for this particular report on which you are working, they will be asked to compare the latest to the 2017, not 2012. That means all those years, all those records before 2017, do not take with your report. Eliminate those rows. The working with the business data, we mainly work with the individual level data like some invoices, some clients, product sales, and so on. And again, it's very important to understand what will be the smallest level at which you will report something. For example, we make decision that the smallest level will be the regional level. Then, during this data import, will be good already to load these data summarized by those regions that you will want to use in the report. This will help shrink the size of the data model. And the last one, if it's possible, try to optimize these column data types. For example, with those postal indexes, if I build report for the one particular country, then, of course, there is no need to show those first two letters. It's enough to show just 4-digit number, which shows this postal index. It seems so small problem. It's so negligible. Just 2 letters. But in general, even those 2 letters in each row summarize up in significant amount of data. Therefore, try to also optimize these data types. And what is also very, very important, try really to think as developers on databases. The STAR scheme is mature modeling approach that is widely adopted by relation data warehouses. And there is a reason why. Of course, there is requirement that a modeler has to classify the model tables as either dimensions or facts. What means dimensions? This is like some classificators. For example, there is a table with all employees in your company, and for each of those employees, in this table show their name, surname, position in company, to whom is reported, and so on, so on, so on. But also is some assigned unique ID for this employee. This is the one-dimensional table. Then there is some additional dimensional tables where is listed all products that you produced, some information about the product, and also some unique assigned ID for this product. The dates, tables, and so on. Those all are dimensional tables. They grow in the amount slowly, times to times, not so regularly. But there is an fact table where is collected all information about observed events. You issue some invoice information. What is included in this particular invoice will be included here in the fact table. The fact table grows very fast. But why there is some reason to use it in Power BI models? Because when these models are well formed, those dimension tables are those which support filtering and grouping when we build some visuals. The fact tables support summarization. Of course, there is more concepts related to these star schemes. Just one additional. There is such meaning as measures. In database, from the database point of view, measures are always those values that could be summarized. In Power BI, keep in mind that measures are not real values. These are the formulas written in data analytic expressions like sums, minimums, maximums, averages, and they produce some scalar results. But those results never are saved in the tables. These are just the formulas that say what variables we have to use to calculate some measure. After all, you will get in the model view something like here you see in this slide, where all those tables are linked to each other. There is unique keys definite. You will see these relationships between tables. Of course, you also can, for the simple models, to create these stars, where in the center you have this fact table, and all around you have those dimensional tables. So, this is very quick and brief review of what you will have to learn during those two blocks. But now, before you go to learn and improve your skills, to make easy for you to understand what you are heading for by following in the learning path, Yevgenis Kaktinch from Elva has agreed to share his experience in working with Power BI. So, Yevgeny, the floor is yours.
So hello everyone. Do you hear my screen? Power BI? Great. My name is Yevgenis Kaktinch. I represent Elva, which is Latvian company, which is working with Power BI. Substantially, the main focus for our company is ERP systems, like from Microsoft products such as Dynamics, so Business Central, like for smaller scale companies. And on top of that, we built data models using tables from Microsoft programs. And beyond anything, we can also use any other ERP systems or Excel files or different sources for like projects and needs which our clients have. So today I'm going to show just how to build a little model based on Microsoft sample data. And in the second part, we'll just look at the already ready-made report and just to look for things where to pay attention for when you build a data model. While Edgars was talking, I was downloading already data for this model, and this data comes, like you see on the right side. I have 6 tables, tables which come from one Excel file. So basically 1 table per Excel sheet. And when I get data from Excel, I'm like provided an option to choose which ones to load into the data model, which ones to skip, and I also have possibility to transform them. So basically, let's have a look what kind of data do we have here, because the first and the very most important step in the data modeling process is, of course, to choose the right data for your business needs. which data do you need, what do you want to represent with your report, and exactly which tables contain the data you need. Is it one table? Are there like some other sources? Like, is it only financial data for your business intelligence analysis, or maybe you need some data from human resource department, or maybe there is a need for some budget data to include in the data model. And when you're building your report, you have to consider all those things. It's not like you load the data once and you can forget about it. You always can add some additional elements into it. So in this document, we have 6 sheets. Like there is sales, like sales transactions, where we have like everything in coded language, like all the products, all the customers are coded in numbers, and it's done not because to hide something this way, but it's the most optimal way how to store the information, because every bit, every symbol, every bit of your records, it takes memory, both in the Excel, both in the Power BI, and memory is precious. So better to store a lot of transactions data, which repeats the same information in a way, in a coded way. So basically, if in this table we have everything coded per transaction, like per one line, we have all the need to know about this transaction, but we decode it with dimensions. As Edgar also mentioned, there are fact tables and dimension tables. The sales table, transaction table would be our main fact table in this data model. And for instance, in product, we can like decode this. These values, we see the product ID number here, we see what kind of product it is, maybe there are some category information, there is some unit price, we can also add some information about like price range, classify those products, somehow add additional rows. Basically, we don't need to repeat all this information in this file, because when we get to know which product is the product 676, we can get all this information by making relationship to this table by like referring to product ID number. The same goes with customers, where we have zip code of the customer and email name, and geographic information. Geographic table contains the how to say decoding of zip code. Here we can go get the information about which city or which state it comes from. And the same, there are some kind of, it's already company specific data, like some campaigns which were launched for several products, but kind of if we want to split our data by this dimension, it's also available in our data model. The most important thing that we have to have this information also in our main fact table. And the last but not least is the date table. Actually, in Power BI, we can generate it directly in Power BI, but in this case, we have it here. So basically, it's date column, and like month, quarter, year. So kind of calendar functions which can be used from Excel, but also we can use it in Power BI and add some more additional things like kind of week numbers or some financial year. If it starts in July, for instance, yeah, we can add some additional rows to this table. So this is about our data source, and if we prepare data source, so we have to think in what format to store it. If there is much more data than 1 million rows of Excel allows, so we have to consider some alternative sources. It could be CSV file, as Edgar's mentioned, but it can also be like SQL database, some large database somewhere in cloud, which we can access to and just load data from to Power BI. As you see, the first step is get data, and we have a lot of sources here. And if we click on more, we can also see that those possibilities of Power BI to import data from different sources is actually unlimited. There are a lot of different sources, Azure Blob Storages, SQL databases, SAP HANA databases, IBM, like even Access, which probably is already forgotten product by Microsoft. You can use also some Power Platform issues like Dataverse, which is a new name for Common Data Service. You can also see here it's mentioned legacy, yeah, but in the future it will be Dataverse. So basically, you can also connect to Power BI dataset, which is already published online. Those possibilities are unlimited. So the Google Store or Google Analytics or Facebook information, basically everything you need, it's possible to make your model and add some data to your model this way. So once we have loaded data, the tables which we load appear on the right side. If we need to transform them, we go to transform data field and it opens the Power Query editor. And here we see all combinations, all the transformations which we have done to our data. If we need to rename something, filter out something, it's the best place where we can do it. Basically, we don't make any relationships between table at this stage. It's just a transformation of data as it comes into the data model. In this view, we see example for thousands of rows in each of the table, and on the top of it, you can also see some kind of column quality information. So if you are familiar with data science, it's kind of also the first step to check, do you have any errors in your data set? Do you have any like outliers or empty rows there? Basically, at this step, you can go through each and every column, choose the ones you need. Like you can choose columns by clicking on this choose column button and like just uncheck those which are not necessary, but there are also ways how to remove them, as Edgar showed also previously. But what's the most important here is to think about the data format as well. As you see in this table, for instance, we have customer ID, which is a numerical format, zip code, which is numerical format, and ABC, like it's a text format for email name. Kind of nothing too important here, and it seems that everything is okay. But when we have the columns like with tables which contain some date values, and if you are importing it from Excel and the regional format settings are different of those which Power BI uses, or there are some misunderstandings, where is the month, where is the date, for instance, yeah, you have to check all those things also. And when you see that your fact table, the most important thing also to go through all your fields and check, do you have like numerical values for your main fields which you are summing up? Like here, in this case, we have units sold of each product to customer and date. So basically, you see customer here is the whole number, like it's kind of not a decimal number, and sometimes there are also those unique fields or record entry numbers. You have also to check that they are in an appropriate format, and the format of the whole number is the most optimal one because it takes less space. So, and date should be, of course, in date format. Sometimes we can see also date time format. It transforms data automatically this way, but you see now we have increased our column twice with unnecessary information. So basically, if you see data in this format, change it to the date format, not date time. Thus, you can twice save the space for your data model. As you see, I changed this the data format for this column into date time, and on the right side, the one more step has appeared. Actually, if I don't need it, I can just click and delete it, and I return to the previous state. And or alternatively, I can also make additional steps on the way here. So very quickly, basically I haven't done any major transformations because this sample dataset is very good. It's also meant for this learning purposes, and I can just transform it and load it in the data model as it is. So once our data is ready, we have it in the data model. So basically, you see there were some changes to sales, and it will load it once more. It should be very quickly because our Excel file is not that large. And on the right side, you already see those data fields. And if you are adding new tables or make substantial changes, there will also appear the changes on the right side. So, and if you open up those tables, you will see all the fields, all the columns you have chosen. They are at your responsibility, they are available for you in your data analysis. So now we can go to the data model view. Like in the table view, you can also see the details of your like fields and columns which you use in your data. Also, just to check if everything has loaded correctly and check any value. So basically, if in the previous step you filter out your data and it has substantial effect on your data model. In this case, if you are filtering something for like if you want to see some transactions for certain date, actually it happens like in Excel, you just filtering them, but the data stays in your data model, nothing happens to it. So once you are sure that you have necessary columns in your data, you can go to the data modeling phase and just see what we have here. Clicking this button on the right down corner of the screen, yeah, it's kind of, maybe you don't see it, but it's very convenient. You just zoom it and see all the model all together. So in this case, what we see here, we have the main sales model in the center. It's kind of our basic fact table, which is connected to the product DIM. Actually, those connections were made automatically by Power BI by analyzing the fields which are available in the data model. And as you see, product ID was connected to product ID, customer dimension, customer ID was connected to customer ID in the sales table. Sometimes you have to create special fields in order to be able to make relationships between tables. But if you have unique combinations and unique, how to say, dimensions which translate those unique fields, yeah, you can use this field and make the connection by that field. So in this way, I'm just thinking in terms of fact tables and dimension tables. In case you have several fact tables, your star scheme may convert to galaxy scheme already and get even more complicated. But the main thing is not to try to connect like a date from sales with date of budget sales if you have another table for facts, yeah, but to make a common dimension for those two fact tables, like in this case it would be date dimension or calendar, connect it to both fact tables and just use this common dimension in your analysis. So both tables will be related and no need to connect two fact tables. Just think about those facts and dimensions this way. In this case, we see that customer dimension has also a little branch on its own. It's kind of by zip code. We can see that these are geographic dimensions. So to conclude, this is not the star scheme anymore. It's already a snowflake. It's a little snowflake because we have additional dimensions which kind of go to the second level of the customer dimension. Usually this also happens with products. If we have like product categories or some kind of lots of levels of products some specific groupings of products which are made in separate table, then we might consider like complicating our model and making even more branches. But in case we have a normal star, then we have to use basically almost all the relationships will be one-sided relationships, and we don't need to bother about that. In case we have a more complicated model, sometimes we might need those both side relationships. Like if I click on the relationship, you can see that we have cross-filter direction, either single or both. And there are also like those many to one, one to many. So the perfect and default way how to deal with it is try to make all the relationships many to one and make them one-sided. If you need those relationships both-sided, you can always use those links also in the measures. But from the data modeling view, one-sided relationships are preferred. And as Power BI classics Alberto Russo and Marco Ferrari say, those both-sided relationships or many-to-many relationships are very dangerous. If you really don't understand what you are doing with those many-to-many, those results can be quite unexpected. Yeah, so basically avoid using them and try to make relationships based on the tables which contain unique values between them. So one transformation I did to this data model is adding date dimension, and it's almost 7:30. Maybe we have some questions from the audience at this point. We can briefly answer.
There is some questions probably you could answer. For example, how to go back to the Power Query detail.
Okay.
Notice that I have to redicate more data tables. Or can I do all the same tricks to the table in the desktop data page?
Okay. Should I answer straight ahead or?
Yes, yeah. I think.
Okay. Yeah. At any time when you wish, you at your exposure is the button transform data. Previously, now the versions of Power BI, it was called edit data. If you use report server version of it, it also would be called edit data. Yeah? But when you click transform data at any moment you wish, you get access to queries which are evaluated at the time of the data loading, and you can also make transformations and add some steps and delete something. Yeah, like let's look, for instance, geographical dimensions. Maybe I don't need that region east or west. I just remove it. This step is recorded here. I click close and apply, and we get our table updated. As simple as that.
And one more question about the importance for the right formatting of the data. For example, someone imports table. There is the data column, which shows, for example, September 7th, 1985. Should first to make a new calculation column to get these dates right, or is there a way how to tell to this column that it contains the date?
Yeah, from experience, I would say this date format is very, how to say, tricky. In this case, like you see that date was stored as year dash month dash date. Sometimes you can use like one this kind of format. Sometimes you can use January 1st, 2020. It depends, but the most important thing that Power BI understands what Excel says, and it might depend on the original settings or the settings of your computer, the settings of Power BI, how they translate each other. But the main point, like when you are in Power Query, you see what type of data you have here. If it is recognized as date format, then you are good to go. You have nothing to do. But if you see that it has transformed your date into some text, usually it's some kind of 14,600. I don't know where it gets these kind of values there, so let's see if I change the format for this field, what happens then. If I transform it into text, you see, it brings it back to the state which was in Excel. Sometimes it's not that easy. If for example, if you are using like Latvian names of the months, and when you are importing it in Power BI, it might cause some trouble if your Power BI doesn't understand Latvian. But if your model language is Latvian, then it should understand it, and it might not understand if you are sending data in English. So you have to try it out. But basically, I check if your dates are okay, then you can use it as a date field. But any time also you can use not only the date dimension generated by date table, I mean calendar table generated in Excel. You can also generate calendar table here if your other tables contain any fields with date in date format. And there is a good function for it. If I create just a new table, and I use this kind of DAX function, calendar auto or calendar. It depends if I have certain values already in mind from where to start and where to end. Okay, you see, in this case, it doesn't find any fields of the date time column. I will change the date okay, I changed it to text and I didn't change it back. But now I will change it to date and it should generate calendar automatically. So basically, if there is no date field in my data model, and probably sales also should be in date format. Yeah, it's also text. You see, this should be, of course, taken into account when I generating the calendar. And then, if there is sales, like sales transaction table or budget table with dates, then it should understand. And now my calendar table should work pretty well. You see that if I just choose this table, in the table view, I have dates from the 1st of January in 2011 till the should be maximum date in my data model. Yeah? So basically, it analyzes it this way. So from the 1st of January in 2011 till 2013. So, and I have also my own calendar table, which was not created in Excel. This way, we can also like confirm that our table contains all necessary date and date format is also present. And in case I consider that my date dimension table is good to go, I can also convert it into the date table. Like by clicking on the table, there is such an option, mark it is a date table, and I have to choose the field which should be the basis for my time intelligence calculations, just in case I need it for my analysis. So basically, marking the table as a date table, showing which field to use. I can mark it as a date, and as you see, probably it's not a good way to use it as a date table in this case, because the table contains gaps in it. So the rule number 1, your calendar table should not contain gaps. And so basically, probably in this case, I would use this automatically generated table and use it as my calendar table. So our data model is there. We have calendar table. I just ignore these gaps at the moment. I won't need it for now, yeah, but it's a good way, like just to check, if you have some problems with your data model. And then actually, you can also add some new fields in this table just by adding columns and using DAX language in your model. Just for reference, there is a site which Microsoft supports, like this is DAX data analysis expressions, or DAX reference, where you have a list of all the functions which are available for you in for different purposes. And as we started with calendar, so basically, if you look here, you just have to find date and time functions, which could be like calendar auto, date. You can extract hour, month, end of month, start of month, and here are also good examples like quarter of your date. The most important thing that you have to have like date column in your data model, and then you can use those kind of simple formulas just to extract this information. If you are coming from Excel, it's quite similar, but sometimes you have a bit more flexibility and some other opportunities. So DAX lives independently of the Excel language, and it provides sometimes very powerful features, and probably you have to study case by case, but the most important thing also based on your need. If you really need it, you can find some information on some community pages, on some forums, because the Power BI community is very helpful and friendly, and they look at different cases and provide like solutions for very different problems, and you can usually find them there if you don't understand yourself much of DAX. But if you understand, it's just a reference how to get that formula. So I won't create anything for this table, date table, but the main principle is just to create a new column and make a formula for it, and you will get your table extended. If just for example, let's take month from date. It's a very simple syntax in the beginning, and you just get a new column with the month number. You can also extract date with a month name. But for this purpose, you should use already a little bit different functionality. Probably it's up to you to explore. If you need, like for instance, weekdays or week numbers, it's like you can look for it how to do it in those DAX reference formulas. I won't too much time on this. But what I want to show for this data modeling thing now, when we have all the tables connected in the way we would like to see it, now we are good to go and connect those data. So there might be a question, why do we need at all the date table? Like if we take our sales transactions and we take like date, and we want to see, let's ignore those customers and campaigns at the moment, but I would like to see like how many units I have sold each day. Actually, it's everywhere one unit. It's very strange. Okay, let's see. Okay, then probably we can take by some other dimensions, like product dimension. If I want to see how many units of each, how it's possible. Oh, okay, we are not summing it. So this is another feature. So at the moment, those units are also stored in text format, although I was checking for this. It's very interesting, but we have to, of course, we have to transform it in the numerical format, so it will be able to sum it up. And so currently, as it isn't considered, one is considered a text, it doesn't sum it up, and so we don't see anything here. So, but now if we want to see the sum of units, so we can use this now we see the sum of each product sold in this data model. So basically, it's very important in order to be able to aggregate data to use those formatting for number. And in this case, we see this is the sum sign on the left side of the field, which confirms that it is indeed the data, the numerical format, and we can use it in our formulas as well. The same way, I have to check now the price of products actually, because then I get concerned when we get the formula for unit cost, or in this case, maybe we can check unit price. Okay, unit price is in decimal numbers. It's okay. So now I would like, of course, it's not enough for me to see how many products I have how many units I have sold. I want to see my revenues for them, and then need information about sales. Usually in ERP systems, there is already amount of euros, which is kind of at my disposal, and I can use that field. In this case, I have only information about units stored in the sales and units sold in the sales table, and the table and the price of this product, which is stored in the product table. And as you remember, those tables are connected. And this means that I can also use those connections in my formulas. For instance, if I have a sales table and I have units field, and I want to see for this product what price for this unit was, and I want to see it and store it in this same table, I can use a new column and use that relationships in the formula. And the formula for related extracting information from a table which is related by relationships as per relational database would be related. So basically, by related, I can get I can immediately see which tables are connected. I can see the tables and table fields, which I can use. And in this case, I go to product dimension and see, okay, I want product unit price here. Enter, and it should give me information about price. If I want to get information about now how many what was the sales amount for this particular transaction and this date, one way how to do it, I can make one more column and multiply the values of two fields, but I will show you how to do it with a measure, because once we have it in the table, once we have data which we want to summarize, we want to filter in some particular way, we already have several options how to do it. And the measures are the most flexible way how to transform data which we have in our data model. So it took quite a while, but now we got the unit price also here. But yeah, if we get information now from the sales table, you see, it's kind of from the sales field, yeah, from units sold, from units. But now if I make a measure out of based on the same field, just there are several ways how to do it, but one of them is right click and make new measure. I will just sum the field for units, and you'll see that the result will be the same, but the way how this information is stored is quite different. So, and here we are already talking about explicit and implicit measures. So basically those which are implicit, those are within the table, and those which are explicit, they are kind of, they are detached from the table, and they are the most flexible way how to transfer what we have in the table. For instance, if we need to add some filter and some, not all the values of my units, but only some kind of products, I can add it into my formula, and it will take it into account. So it seems it thinks a little bit too long at the moment. But yeah, now it should give me opportunity to create that measure as well. So by just summing, similar as in Excel, I'm showing which field I want to sum, and this would be the same units from the sale table. and I can call it units sold. In case I would need to add additional filters, I could already use like some overlay on this formula, like calculate, and say which filters to use to calculate this sum. In this case, it would be just a simple example, just to get you prepared for the next stage, probably in your Power BI exploration path. Yeah, so just creating simple measures, and then you can build upon it. And once your data model is connected and all the relationships are met, you can use all this information about available dimensions, filters, and related fields in your analysis. And so, now we have units sold, but what could we do to create a measure for sales? As I showed in the table, you could just multiply two fields, like units, number of units multiplied by unit price, and we would get sales per row. But with measures, if I sum the sum of units and multiply it by sum of unit price, of course, the result will be total nonsense, because I don't have to multiply all the prices by all the units. This is another feature of the DAX language we have to talk about. But once we have units sold measure here, so basically you see the result is the same. There are units and units sold, but the implementation is different. In one way, we use the field from the table. In another case, we use a measure. So basically, if we are unclicking units, we are just left with this measure, and we can operate in our future formulas with those measures alone. Now I will create the measure for the sales. And just briefly, we can visualize it. What is the result of our basic steps in data modeling? So when I'm in Teams and when I'm working on Power BI, sometimes it takes too much memory. It is like that. So basically, you have to consider this when we are sharing.
But while it's loading, I will ask one question from the public.
Okay.
And it's very good related to those measures. This is course for the beginners, and so there is also this question: is it preferred to use measures or get the read data directly from the data source?
So basically, you use data from the data source in any way. But with measures, you are making those calculations much more flexible. So basically, if you are taking the field and it is like units and you have a product, it will give you, like, for every product, it will aggregate the sum of units for it. But if your measure needs some more intricacy in it, if you need to work like to count only those products which have been categorized as like top 5 products and calculate only sum for those units, you can't take it from the table without filtering out all the rest. You have to use measure, and in measure you can like limit your filter, limit your like calculation logics by adding additional filter on top of it. So basically, and if you have like those time intelligence calculation, like calculate some last year, calculate some last month, calculate some this week, or calculate only some of today, like product sold only today. So basically, these are all measures. It's impossible to do it at the same time and take it from the table, filter out the table for today, for instance, and have at the same time also the value for the last month. That's why we use the calendar table, and that's why we use time intelligence formulas for this kind of calculations. Okay, sales. So as I said, we can't just sum the sum of units and use the sum of prices, because it will give us a totally incorrect result. And for such calculations where we use row level, like calculations on row level, we use the iterator functions, or in this case it would be sum x. X means that it goes step by step, like row by row, and calculates the formula which I will provide in the formula. Yeah, calculates this expression for each row separately. In this case, it would be sum of units sold, which would be already, for instance, that unit sold measure, which I have created, or it can also be explicitly written, sum of units sold from this table, and I will calculate for each row units sold by unit price. And now I get the sales for this row. So, and this is a good example how to use this iterator function, sum x. It can be also average x, or it can be also min x or max x. So this is kind of all those calculations which happen on row level would contain that x. If I need the aggregation on the whole table, I use the function without x, and if my calculations are needed on the row by row basis, I use this iterator function. So aggregators and iterators, one very important concept for DAX. And now, as you see, I have products and sales. I can probably use also those dates, maybe just to illustrate. Let's take away the product just by date. Let's see our units sold, sales by date. Yeah, they are different. It's okay. And one more thing. Yeah, if we are using date field, sometimes you'll see that it brings you all the hierarchy here. And in this case, I have all the months and the quarters in Latvian. I can also use it if I need, but I can also hide the hierarchy and use only one date value. And one more thing for date value format, you see now it's the weekday and the week, month and year. I can also modify this format how I see this date, and I can use it just a numerical field for it. And once I set it, it will work for all the data model. So now I can see information about data and sales for my by each date. And if I want to see it in graph, now I can very quickly also use this information in the visual format, transform the table into visual, just not to lose the side of the table. I save it as well here. And if I transform it, for instance, to line chart, which is a preferred way to look at data, and I will use only sales by date, for instance. Yeah, and in this case, I can leave the hierarchy as well. So now I can see all my sales by date, and I have the hierarchy at the moment. So now it shows years. They can use drill down functionality, and I can split my date. Now it is by years and months, and now it should go quarters and months, and now it should go years and months. And this way I can analyze why those peaks were like that, analyze what has influenced my sales, and all other interesting things. And it also, as all our model is connected, I can also use additional features of Power BI, like just click any point I'm interested in, right click and look at analyze, and okay, it can explain why this happened. So why there was decrease. And now Power BI generates some artificial intelligence behind it and analyzes why there was an increase of 19% in sales between November and December. And you see the analysis was quickly generated. So basically this was created by these we see the sales for November and December, and those bars show which categories have been influencing our sales. And if I like this visual, for instance, yeah, I can also add it to this page. And now I have like without much thinking, I already have the two visuals on my page, which explain some science patterns in my data field. So yeah, this would be it, like for introduction for simple data modeling. I would say I'd like to inspire you to explore it further and create your own models, which would be much more complicated. And I hope like Microsoft Learn materials allow you to practice those skills and understand better why we need iterators, why we need aggregators, to learn some DAX and like show your data with some interesting insights. So yeah, and thanks a lot. And I give floor back to Edgar. So, yeah, maybe there are some other questions as well.
Thank you, Evgeny. But before I let you go, there is some questions. I think this will be nice if you can answer to them today already. For a lot of other questions, we will give the answers later after our webinar. Yeah? But first, during your presentation, there was a very nice picture where was possible to you how many cases are valid, error, empty, above the columns. And this question is how to add something like that when you import.
Yeah, good question. I think by default it's not there. Yeah, I noticed. Yeah, it's not there, but yeah, it's a data quality thing which we are thinking before we are loading data. So you are talking about these fields there, yeah, on top of the column.
Yeah.
So it's called column profiling. Yeah, it's shows which columns are valid and so on. In the view field, in the view tab in the Power Query. So I went to transform data. I pushed transform data button and went back to the Power Query. And now you see here are like column quality checks. Yeah, if I take it away, it's not there. Probably by default, it's not there. Maybe formula bar is not there as well. You have to check it back if you want to see what's going on here. Actually, you might not understand what's going on here because it's already different language. It's an M language used here. If you are using advanced editor, you can see what query is generated at this stage in totally different language already. And sometimes it's very easy to just change the, for instance, data source. Now it's my computer data file. Yeah, I can just change it to another destination. I'm good to go. I can use the same model with different data source. Sometimes you can, like this, you are like able to make some interesting combinations as well. But of course, automatically, it's much more easy. So column quality is one thing which we can add. We can add also a column distribution, like we can see how many distinct or how many unique values we have in each of the columns. Sometimes it's very useful, and by this you can also optimize. If you have like a lot of those Edgar also mentioned you have to consider a level of granularity in your data model, how detailed is your data. This also influences how many unique values you have in your data set. And actually, if we are going to sales, you will see like at the moment, we don't have indexes for each of the transactions, but if we would have it, so you would see that all those values would be unique in that field. So this way we can also like optimize it a little bit. And if those values are too different, maybe to think how to optimize those as well. So, and another thing is also column profile, where you can also use like it doesn't respond to my actions at the moment, but here these are the things how to analyze the data preview and see how many errors you have or how many unique values. So this everything helps there. Yeah, this view tab, and you can uncheck or check the fields which you are interested in.
Those are very useful tools, but related to that, in your everyday experience, there is one more and the last question for today. The question starts with that statement that no, of course, it's reality that for the lot of companies already, the data are connected with Power BI or other business intelligence tools. How much of your time takes to validate data, import data, and etc., and how much time of your work takes to actually analyze the data?
Mm-hmm. So basically, it's about my personal experience.
Of course.
Okay. Well, what can I answer? I'm not working alone. And the data preparation actually part is taken by colleagues which are working with Navision or like Exapta data, like Business Central or Dynamics data. So basically, when I connect to the model, it's already there. So I'm kind of lucky in this sense. I have to just check the data is there, because these are standard columns, these are standard set of tables which I can use. But if I'm working with the source, like for instance, we have added the Salesforce tables, like these opportunities, yeah, for sales representatives, which they see and added in the special online platform Salesforce, and we like integrated it in the data model based on Exapta data. And in this case, you have to go through all the tables to see what values we have there, which fields are useful, and it takes time if you don't know the data source, of course. And yeah, this is, and for data scientists, of course, the data validation field and data clearing is very important step.
But if you talk about this process as the project, never mind that how many people work, how many work hours will be spent on data preparation, and how much work hours for analyze?
Ooh.
Approximately.
It depends on the data size, and actually also those data sending, like times, how big is the data, yeah, how time it takes to transfer it from one data source, like to the SQL database, for instance. It all takes time, and you have to take into account that there should be refreshes as well for those data. But data preparation, to be able to make a data model, like it should be as standardized as possible in order to not to overload this. But for big projects, actually, for how to split those hours between the data preparation and data analysis, it also depends what we analyze. It's not like 50-50, or it can be also we spend like half time of the project on data preparation, and or maybe 1/4 of data preparation and 3/4 on the data analysis, because linking all those tables together, finding the right values, like adding some additional files from Excel, for instance, it can also take time to just to analyze what are your business needs to add this. So basically, yeah, it's these are important parts, but it's very hard to say how many hours exactly. But for big data projects, it will take the more the data, the bigger the data, the larger time to analyze it, of course.
Thank you, Evgeny. Very large thank for your presentation. It was very, very fruitful, very useful, I think, will be for all.
And as I see, if you are in the middle of your course on Power BI, you explore much more interesting things as well, but it should give you a very good understanding which things are really important in terms of data formats, in terms of what to consider when you make DAX formulas. So I hope it will be useful for you as well.
Thanks. And thanks also for all who joined today's webinars. Try to stay curious, and see you at the next webinar in 2 weeks. Bye.
Bye-bye.